So I'm just going to wait for a few minutes and allow everybody to join. Okay.
Okay. Okay. Okay.
Yeah, sorry about that. I'm just trying to figure out the sound thing. I think it's okay now. So I will start with the problem I left last time. I left a problem for solving last time from week 2. So I'll start with that. Just give me a moment. I'll share the slides from the previous week. So this was the question. As you can see, we are given the demand curve and we are given the supply curve in an algebraic form. This is not like you're not given numbers or something. You're just given the curve in an algebraic form and you're just asked to calculate the equilibrium price and quantity. So I will first solve this and then we will move on to week 3's content. So let's first start with week 2. Let me open the question here again. Okay, so let's go. This is week 2, question 5. And you are given QD is equal to A minus BP, QS is equal to C plus EB. So as we know in equilibrium, there is only one unique price and one unique quantity, right? So all we have to do is we have to equate QD equal to QS and then just solve the thing algebraically. So in equilibrium, it's more like theta. So this is your price, right? And now we substitute the value of this price into the any of the equations for the quantity and we obtain the quantity. So say suppose I take the value of QS. QS is C plus EP. C plus EP into P is this. Right now, this is like just an algebraic expression which you need to simplify. So you can take this up. So this is your quantity in equilibrium. So you have the you have the equilibrium price and the equilibrium quantity. So let me just open the options I had given. There were several options with like slight variations in the expression. So the correct expression is A, which is AE plus CB upon B plus C as the quantity. You can put Q star, whatever. And price is A minus C upon B plus C. All right, so this is just what I gave for solving in the previous class. Now let's go to, okay, not here, this one. Okay, hang on. Let me just open the file. So this week we will mainly focus on price elasticity of demand. There are other types of elasticities also, which we can just briefly touch upon if you want to. And the second aspect we are going to discuss today is mainly taxes, right? Incidence of tax. So before I go ahead, if you have any questions on either of these two topics, you can let me know. You can just type it into the chat box. Otherwise, I will just go ahead and start with today's class. Okay. So can you see my screen? Okay, I don't think so. Let me stop and share it again. Okay, I think it's still not connecting. Hang on. So let me exit and try again. So, and no questions so far? Because today's topic is a bit important and there's a lot to cover. So I will sort of, be going forward as, not fast, but like, yeah, we do have a lot to cover. So let's hope this screen share works. Yeah. Okay, so this is the first um, thing you need to understand about elasticity, most basic thing, which is like what are the factors which affect the elasticity of demand for a good. And before we come to the factors which affect elasticity of demand, I think it's kind of important to understand what do we really mean by elasticity of demand in the real sense, in like the tangible sense, so to say, right? So when we say elasticity, I mean, general example people give is that of, say, a rubber band or something, right? Like how much it can stretch. And now if that helps you, that is great. I personally feel like you need to be clear about what it means in terms of the price comparison that you're talking about. So when we say elasticity of demand, we mean that, how responsive is the demand to a change in price. So if you change the price by, say, some quantity, is the demand changing very much or very little? That is the meaning of price elasticity of demand. So when you alter the price, for example, and it helps to think about, like, everyday goods you consume. So for example, like maybe you read books, or maybe you use laptop, phones, whatever. So if there is a change in the price of, say, a textbooks, how likely are you to still buy the textbook? And similarly, like if this the cell phone prices, say, increase and they become more expensive, are you still going to buy the cell phone? So what we mean by price elasticity of demand is how responsive is the demand to a change in price. Now, which of these options do you think are going to affect the price elasticity of demand? Is it like A, B, C, or all of them? So unfortunately, I think we have low attendance in the class today. But you can just type in your answer in the chat box, or you can unmute yourself and speak. Either is okay. Anybody wants to try? It's okay if you're not sure, that's all right. Because when we talk about these items, it's also kind of important to understand like the rationale there. Like why, for example, if availability of substitutes affects the elasticity of demand, then why does it do that? Similarly, if I'm talking about, say, size of item purchased, like why would it affect it? It helps to think in terms of why. At least that's how I figured it out. So I'll go over these one by one. So let's start with the availability of substitutes. So for example, like, if you have, one kind of an item, say like a textbook. I was giving an example of a textbook. Now, if the textbook has some other really good alternatives, like if you have some free online course, or even if it's a paid online course or a paid online ebook, for example, but it's less pricey than a textbook, and if the prices of textbooks increase, you are going to be less likely to buy the textbook if you have really good other alternatives, right? So if the and we know that the prices of several of these items do in fact change now and then, and our purchasing behaviors also get modified over a period of time. It is simply a question of just bringing a little bit more of, like, the economic sense into what we are already doing. So when we have a lot of substitutes, we are generally going to be less likely to buy an item with an increased price, right? So like, for example, I gave you the example of a textbook. If the textbook was costing 500 bucks and now it has become more expensive, it is now going to cost me 800 rupees. But there is an online textbook which is, say, 300 rupees, or whatever, some smaller price, but it's just as easily substitutable for the textbook, then I'm less likely to buy the textbook after an increase in the price. So availability of substitutes definitely affects the elasticity of demand, right? Because it is affecting how much I'm responding to a change in price. Now, next is the size of item purchase. So when we say size of item, it doesn't necessarily have to mean like the physical size. It can be like, how cheap or how expensive or how much that item is kind of occupying your monthly expenditure. You can think of it in those terms also, apart from, just how big or small something is. So, for example, like, if I'm buying toothpicks, right, a pack of toothpicks, if it used to be 100 rupees and now it has become 130 rupees, I'm not going to bother that much, right? I'm not going to be so sensitive to its price change. But if it's like, say, something like a car, like an automobile, right? If the prices increase, I'm definitely going to be a lot more sensitive to it because it's, first of all, it costs a lot. And secondly, like, I will want to wait to see if if the prices change again. And I'll buy it, when I have saved more or when I have higher disposable income or whatever. Right. So the size of item purchased is going to affect the elasticity of demand. Right. The next option here is time frame of observation. Now, time frame of observation is like something like within a day or within a month or a quarter, whatever. So, when the price changes, sometimes like the immediate response is that there is a drop in demand, or if the price is lowered, there's a rise in demand. It can be both ways. But over a longer time horizon, like a longer period of time, over say 1 year or over 2 years or 6 months, the demand may sort of, adjust itself, right? Like maybe you tried out some other substitute and you weren't very happy with the substitute and you go back to that product, even though it's a little bit pricier now, right? So all these factors actually do affect the elasticity of demand. And maybe some of this is not like covered in these exact words. No, right? Let me just give me a moment. I will reshare it. I think this kind of goes on standby or something if I don't like do anything on the iPad. Okay, so let's see. This is an application example. So after the invention of nuclear power plants, what do you think is going to happen to the demand for coal power plants like fossil fuel? So if you have an alternative energy source like nuclear power plant, what would its impact be on the elasticity of demand for coal power plants? Anybody wants to try? It's just an application of what I was just explaining in the previous question. Yes, so somebody's answer, it'll be more elastic, right? Because now you can, now if say, for example, the price of, power you are getting from a coal power plant, if it goes up, or even the coal power plant itself, if it becomes, say, more costly, if it's more expensive to, build or establish a coal power plant, now you have another alternative. So if it's too expensive, you can just switch to power generated from a nuclear power plant. right? So in places, for example, where you have that alternative, where instead of coal, you can switch to, now in this example, I've taken nuclear power plant, but it can be some other source also, like it can be hydel power, it can be solar, it can be any other renewable energy source. So, I mean, I think in India, you still don't have that kind of easy, you know, option to switch to your choice of, say, power source, right? But in some places you do. So if you have the option, if coal power is costing you a lot, and if you have the option to switch to some other energy source, some other power source, your demand for power from coal plant would be definitely more elastic because you have an alternative. You can just switch, and it's kind of helpful to think of elasticity. I was just reading something in one of the online books and stuff, to think of elasticity as like a possibility to escape, right? Like how easy is it for you to escape from that particular good or that particular, you know, commercial thing. So if it's easy for you to escape, like if instead of coal you can use something else to generate power or to use power, that is like kind of like escaping from, you know, the coal power dependency. So if it's easier for you to escape from it, your demand for that particular thing is more elastic, right? That is what elasticity is trying to capture here in economic sense. So I hope that helps. Now let's just come down to the basic nuts and bolts of how you calculate elasticity. I've given a function here. The market demand function for corn is given by this expression, Q is equal to A minus BP. And you are asked what is the price elasticity of demand, like what is the expression for price elasticity of demand, given that the price is P. And then you're asked that if the values of P, A, and B are this, then what does the elasticity come out to be? So I'll just give you 2 minutes to calculate this if you like, and then I'll solve it. So I want to give you a chance to try it out yourself first, and then if you don't get it, I will solve it. I'm here, I'm just muting myself. So anyone wants to try? Did anyone solve it? No? Oops. I don't know why am I seeing this? Yeah, sorry. Okay, let's solve this question. Should you incorporate minus sign? Yes, minus, like, you know, even in this, like even algebraically, you cannot just like forget the minus sign. And in elasticity, you should definitely include the minus sign. Let me open the question for myself. Okay, so this is now week 3. And this is question 3, right? All right, so you're given Q is equal to A minus BP. The P is the price of corn. So now we generally use epsilon to like represent elasticity of demand, price elasticity of demand. So the easy peasy expression for this is delta Q by delta P upon Q by P, right? This is the, this is like the simpler, easy version of price elasticity of demand, right? So now if you want to calculate it, instead of this delta, what we can do is we can instead use calculus, and we can just make this into dq by dp upon q by p, right? So in this case, you're given the expression for q, so dq by dp comes out to be just minus b, right? So epsilon is equal to dq by dp is minus b upon q is a minus bp, and p is just p. So p is going into the numerator, so this is p. So if you want, you can like simplify this and make this, rewrite this as bp upon bp minus a. I just brought the negative from numerator to the denominator. Both are correct. You can write it in either way, just to make it a little bit neater, a little more sanitized. I have put it in this way. So the expression is this BP upon BP minus A. This is the price elasticity of demand. And now we are asked to solve for this given, so let me write this, given P is equal to 10, A is equal to 60, and B is equal to 1. So it's pretty simple. You can just plug in the values. B is equal to 1, P is 10, B is 1, P is 10, minus A is 60. So you get minus 1 by 5. So the answer in the question is option B. Okay, so this is not complicated. It's pretty straightforward. Now we come to a slightly different kind of a calculation for price elasticity of demand. And that is, we're just trying to put it into practice, right? How would you apply price elasticity of demand on, say, everyday kind of situations, right? So now say, suppose you're given the elasticity of demand for this travel package, spring break package to Cancun, and the elasticity of demand is -5. Now, one thing to notice is that we will generally find that the price elasticity of demand will be written with a negative sign, -5 or -1 by 5, -2, whatever. And that minus carries a meaning, which means that an increase in price is associated with a decrease in the quantity. And this is not like some coincidence or something. This is follows from the basic definition of a basic expression for demand. The demand curve is downward sloping, right? So obviously when you calculate, when you take delta Q by delta P, if P is increasing, Q will be decreasing. So delta Q is going to be negative. So this minus is always going to be there. And if you are asked to solve for price elasticity of demand anywhere, unless they explicitly ask you for just the value, like, just the numerical value, you should always write it with a negative sign, because some places it can actually be marked as wrong if you write it with a positive sign. Okay, so this is just a note. Okay, so you're given the elasticity of demand for spring break packages to Cancun, which is -5. And if you notice that this year in Cancun, the quantity of packages demanded has increased by 10%. So you know the increase in the packages being demanded. So what you're asked is, what happened? What do you think happened to the price of the Cancun vacation packages? Has it fallen? Has it risen? By how much? That's what you have to calculate. So an easy question actually. Okay, somebody has calculated it. Good. Anyone else? In this, you don't need any calculus. Also, you can just do it like just arithmetically. Anyone else wants to try? No? Okay, so I will quickly solve this. Okay, this is question 4. You're given E or epsilon is equal to minus 5, and you're given delta Q is equal to 10%, or it's equal to minus 1, right? And you're asked what is delta P, right? So epsilon is equal to delta Q by delta P upon Q by P. And what we are being given is delta Q upon Q and delta P upon P. So this can be rewritten in this way, right? It's the same thing, right? This is just the same expression. I have just brought the Q up and the delta P down. It's the same kind of expression. So epsilon is equal to minus 5 is equal to what we know is delta Q by Q. This we know is plus 0.1. And we want to know delta P by P. So this is pretty simple. You just take delta P by P on the other side, 0.1. Oops, sorry. 0.1 upon minus 5 gives you minus 0.02 or minus 2%. Let me write it properly. Okay, so this is how you get minus 2% is the answer. So the price fell by 2%. So we see that if the price elasticity of demand is minus 5 and the price is falling by 2%, then the quantity demanded is increasing by 10%. That's, you can see like this, like, so, it's like a pretty decent increase in quantity demanded, right? You can see the price elasticity of demand is minus 5, means it's fairly elastic, the demand. Okay, just give me 1 minute. I'm getting a call. Okay, so I have to go for just 5 minutes. So let's just take a break here, and I will come back to taxation. And I'm just leaving you with this question. In the meantime, I will be back in 5 minutes, and we'll continue with taxation. And there is another question which I was solving in the previous class, which, if you remember, it was a logarithmic question, and I didn't solve it correctly. So I also want to just solve that question once. So I'm leaving you with this question just as food for thought, and I'll be back in 5 minutes. Okay, so let's continue where we were. So we finished, or we kind of completed the part about elasticity of demand, and we're just moving from elasticity to taxation. So there are like several things about commodity taxes, which when we say commodity taxes, so far we are kind of referring only to the unit commodity tax, meaning like the tax which you are charged per unit of the commodity or the good. So we will come to something called the ad valorem taxes, which is kind of very common in India, but we'll come to that later. First, let's talk about the tax, which is like, a lump sum kind of a tax, which is like a, not lump sum actually, but like which is sort of based on the quantity. So if the tax rate is say T or tau, the tax you're paying would be T into Q, or tau into Q, right? So that is the tax we are talking about, generally speaking, unless otherwise stated. If it is something else, you will be told that it is something else. So since we have been talking about elasticity of demand, and I think elasticity, I didn't talk about elasticity of supply in the questions, but it's a similar concept, and I think you've covered it. So when it comes to actual incidence of tax, who do you think pays the tax, and who do you think is legally obligated to pay the tax? Are these two related, or are these two completely different concepts? That's what the question is asking you. So which of the following statements is or are true? So the first one is, who pays the tax does not depend on who is legally obligated to pay the tax to the government. This is what the question means, that who the incidence of tax is falling on, is it the same as the person who's legally obligated to pay the tax, or is it something different? So what do you think it should be? Is this statement true or not true? Okay, so one person has answered, good. So the first one would be that they may or may not be related. So, in some special cases, it is possible that, the person who's legally obligated to pay the tax is the same as the person who bears the entire burden of the tax. But in majority of the cases, that may not be true. For example, like maybe the seller is footing the bill, or is footing the, is filing the taxes, is paying the check to the government, but the incidence of tax is not borne entirely by the seller, it is borne partly by the consumer, right? The second thing is, who pays the tax does depend on the elasticities of demand and supply, and we will take an example for this later too. So this is kind of a very important point, and for this reason especially, it is important to estimate the elasticities of demand and supply for the producers and the consumers, because and for the government. For example, like if the government is considering applying or levying a certain tax on a certain good, like say, you have some examples in your coursework also, so I can't take an example from your assignment, but say there is some narcotics, or there are some drugs, or some good which is like harmful for some people. If the government is considering levying a tax on that particular good, whether it is actually even useful to levy that tax or not is decided by the elasticities of demand and supply. So if you want to say, like, tax people for, say, tobacco or something, right? A lot depends on how easy it is for the consumer. First of all, number one, the consumer to switch from tobacco to something else if the prices of tobacco rise. And secondly, even for the supplier. So the companies which are, say, manufacturing tobacco, if the incidence of tax is on the supplier also, then how easy is it for the supplier to just switch to manufacturing some other substitute good, which may not have that kind of a tax, right? So if the demand and or supply are fairly elastic, and the government decides to sort of levy a tax, then sometimes some really untoward, unwanted outcomes can be found. So like I was just reading an example a few days ago. I think once, like in the 1990s or something, the US government, imposed a tax on yachts. Right? It's a luxury tax, it's a luxury good. And they thought, let's raise some revenue, tax revenue from, this particular good, which yachts are pretty expensive, right? So they levied some very heavy taxes, like 10% on something maybe on yachts. And what they found was that the demand for yachts was actually very elastic because it's a luxury good. So people are not like dying to buy yachts or something, right? They can totally do without a yacht and buy something else, or just buy it in some other country, because they are like, these are like, by its very fundamental feature, the yacht is anyway supposed to be moving all over, right? So the outcome of that was that they were expecting to raise something like 30 million in tax revenue. But what actually happened was that they raised only like 16 million in tax revenue. And instead, because of this increased prices of yachts, like because the sales dropped so much after the price change, after the taxes, there was a very significant loss in jobs in the yacht industry. So something like 7,000 or something jobs were axed off, right? People lost the livelihood. And then the government ended up paying them unemployment benefits to those people who lost the jobs because of these price hikes or taxes. And whatever they paid to those workers in unemployment benefits was more than the revenue the government had actually made through the taxes. So the lesson was eventually that, before the government decides to, say, levy a tax which would definitely alter the prices and would definitely shake up the particular industry or that supply and demand for a particular good, it is extremely important to know what the elasticity of demand and supply is. Because unless you know that, you can land up in a very dicey situation and you may get a completely opposite outcome of what you wanted, right? So for example, people, like I was talking about tobacco, maybe people might switch from tobacco to something else, some other kind of a good, and the taxes may not even work, and they may even switch to something more harmful. So you have to have these parameters ready on account. Okay, so the third point is that taxes raise revenue for the government but create lost gains from trade. So this is also true, and it's of course there in your lectures, and you will also sort of cover it. So the answer is all of the above. And I'll now take an example. So say suppose there is a mineral which is in fixed supply. So the supply equation is just QS equal to 4, okay? And the demand for the mineral is given by this expression. QD is equal to 10 minus 2P, where P is the price per pound and QD is the quantity demanded. Now the government imposes a tax of $2 per pound. Your pound is the unit of weight. Remember, like how we have kgs, they have pounds. So don't get confused, because I don't know for what reason they decided to name their currency and their unit of weight the same thing. But in this case, pound here refers to weight. Okay, $2 per pound on the consumer. So the incidence legally is on the consumer. Actually, what it is, we'll come to that. So before we talk about the price received by producer and the tax burden and all of that, first, can somebody just quickly solve for the equilibrium price and quantity before taxes and tell me what it comes out to be? Okay, let me also solve it along with you guys. Question 6. So you are given QS equal to 4 and QD is equal to 10 minus 2P. Okay, somebody has solved it. Okay, good. So QS is fixed, right? Supply is the same, irrespective of whatever else may happen in the market. So therefore, you can do QS equal to QD. Therefore, you can just put 4 is equal to 10 minus 2P. P comes out to be 3. Therefore, at equilibrium, P star Q star is equal to 3 comma 4. Right? This is before taxes. Now you have a tax T of, how much is it? $2 per pound. So I'm just writing it as 2. Now what you are asked is, what is the price received by producer? So first, yeah, let's talk about what is the price received by producer. Let's write this as PS, because let's say S is supplier or producer. So what do you think is the price the producer is going to receive in this case? One, exactly, because in this case, I'll draw the diagram now, or let me share the diagram. So this is your how do I make this big? Yeah, so this is your general diagram, all right? So this is, I will come to our question, but let me just quickly go over the mechanism of tax incidence first. So this is like a regular demand supply curve, right? Demand is downward sloping, capital D. Supply, the blue curve is the initial supply, and the red curve is the shifted supply after taxes. This is a generally situation, not referring to our question. I will come to our question also. So in this situation, you can see the intersection point. Okay, this point is the equilibrium point, right? And this yellow triangle is the consumer surplus, and the pink triangle is the producer surplus. And you can see what the T you can see marked is the tax burden. So this is like, this is what we call as the tax wedge. So if you just take the quantity of the tax, which in this case is 2, we'll come to that. And if you just map it vertically between, say, this, suppose this is demand, this is supply, you know what the quantity is, T. And if you just put T here, that is your tax wedge. This last part you can actually erase. I was just drawing the price line, but okay, let me draw it on this only. So like, you know the demand and the supply, and this is your tax wedge, right? Now in this, you can see at the point where this tax wedge is cutting off the, the original supply curve, that is the price the producer is going to get. And the point where this tax wedge is intersecting the demand curve, that is the price that the producer is going, the consumer is going to pay, PC. I'll repeat it because I made a mistake. So the point at which the tax wedge, in this case, you can see this marked with this double pointed arrow, the point where this tax wedge is cutting off the supply curve, the original supply curve, that point decides the price which the supplier is going to pay. And the point where it sort of intersects the demand curve is the price which the consumer is going to pay. PC and PS, you can see this here, okay? And the P star is the original equilibrium price. So now whether you see this as shifting of the supply curve or the demand curve, based on, whether the tax is imposed on the seller or the consumer. In this case, we have shifted the supply curve because the incidence is on the seller. When the incidence is on the consumer, you generally shift the demand curve. If you remember the lectures, like, the result is the same. There's no difference in the result, but the elasticities of the two curves is what is really important in this case. So in this case, I'm just going over the fundamentals so you don't get confused when we talk about the special case. Now this red triangle, this red hashed triangle on top, this is the consumer surplus after tax, right? And yeah, this new triangle, this blue hash triangle, this is the producer surplus after tax. And okay. All right. Let's do this again. It's not changing things. All right, so let's do it like this. It's not showing the triangles, but now you can see, I hope. So this, I have marked this area. This orange box, this this orange box, this is the tax revenue which the government generates. Okay, this goes to the government, and this green triangle is the deadweight loss, right? This is hopefully, this is covered in your lectures. I'm just recapping it over here. So this is how you normally compute the producer surplus, the consumer surplus, the tax revenue, and the deadweight loss. Now let's see what happens in the case of inelastic supply. So this is your inelastic supply, which is what we have in our particular question. So in our case, we are given this value QS equal to 4, right? In this case, in our particular question, this value is given to us. T is given to us as 2. Initial price was 3, right? Now in this case, you can see that, even though the tax is imposed on the buyer, when we impose tax on the buyer, we shift the demand curve, not the supply curve. And in this case, anyways, supply itself is fixed. So when you shift the demand curve and you apply the tax wedge T, you can see that the point at which the demand curve is intersecting the supply curve is such that the entire tax burden is being borne by the producer, right? Because you see now where the tax wedge is intersecting the supply curve, it is intersecting the supply curve at the point where PS, the new price for the supplier, is P minus T, which is, in our case, P was 3. So 3 minus 2 is equal to 1. Okay, my annotations are sort of lagging. It's coming a bit slowly, but anyway. So this whole producer tax burden is like the entire tax burden. The consumer is not taxed per se. The consumer, even though the consumer or the buyer may be obligated to pay the tax, the burden is actually coming on the producer, right? And in this case, you can see that this is like the demand curve. You can see initially this yellow triangle. This was the initial consumer surplus, and now the demand curve has shifted. But if you take the area of this triangle and this triangle, they're like they're the same, right? So the consumer surplus is basically not changing. And let's go back to what our question was asking once again. So the question was this, and this next question is, what is the deadweight loss due to tax imposition? So how do you think you will calculate the deadweight loss? And why would there be deadweight loss? I can share the diagram again. So this is the diagram. So in this diagram, we see that there will be some deadweight loss. Why? Because, let me use some other color. Because you see that there were certain sales which were happening earlier, which are not going to happen now because of the taxes, because the producer is receiving a lesser amount, right? Now you see this whole T thing. How do I, actually I don't need to hatch it. This blue, you can see this blue rectangle, right? T is equal to 2 is its one side, and 4 is the other side. This whole thing, all these transactions, they were happening earlier in the original situation, right? In the original situation, this was the equilibrium. This was equilibrium without tax. Now this is the equilibrium with tax. So all these sales here, I will delete these annotations when I upload the slides. So, I mean, I know it's looking dirty, but I don't really have any other way of explaining. So this whole blue triangle with that ugly hatching was basically a certain number of sales which were eventually happening, but they're not happening right now, right? So this is going to be your deadweight loss. Is this making sense? Any doubts about this? Because this shifting has happened only because of the taxes. Now, again, in this situation, the shifting is we're representing it with a shift in the demand curve because we are imposing tax like legally on the consumer. So D is shifting to D prime instead of the supply curve. Wait, sorry, the sale is 4. Yeah, actually, you are right. 1 minute. I think, just give me a moment. Let me just reopen the question. Sorry, just give me a minute. Yeah, I'm so sorry. I think I typed the question wrong. This is not the deadweight loss. This is actually the tax revenue raised by the government. I was typing another question and I missed I rewrote the question. Sorry. I will correct this in the slides which I upload. It's written wrong in the question. Yes, I'm sorry. That blue triangle which I was showing you is not the deadweight loss. It is a tax revenue. 1 minute, let me change this. Okay, I've not written it, so it's okay. So this thing is not deadweight loss. Sorry, this is the revenue due to tax. Yes, because there is no change in the sales. The sales are still Q. There is not going to be any kind of difference in the in the sales, in the number of trades that are made, but you will still have a difference because of the revenue. So the government is still raising this particular amount as the revenue. Okay, so any other doubt? I'm sorry I made that mistake. Any other question about this? So the rest is as it is, as whatever I explained, just this part I messed up. Okay, that question is typed wrong in the slide, and I will fix it when I upload the slides. Okay, so let me go back to, yeah, so this is also like a similar example which I wanted to take. I didn't find a proper question on this example, so I've just made the diagram. So in this case, we are imposing the tax on the seller, but instead of the supply, it is the demand which is perfectly inelastic. So in this case, you see that the demand curve is a vertical line, right? And in this case also, because the demand is a vertical line, meaning there is not going to be any change in demand, irrespective of whether there are taxes or there are no taxes. So this is the original equilibrium. And this is the new equilibrium. And because the tax is actually imposed on the seller, we are shifting the supply curve. So this shifting of curves doesn't matter in the final outcome, but if you're asked to sort of draw a diagram, or you're asked to kind of represent it on a diagram, which curve you show as shifted will matter. So, if the tax is legally imposed on the seller, you should ideally be shifting the supply curve, right? Now, in this case, you see that when the demand is perfectly inelastic, the entire tax burden is coming on the consumer, because you see, like, when we take this tax wedge, this is the tax wedge, T, right? And you just map it from the supply to the demand, and this point of intersection is what you get as the new price for the buyer, right? This is the point where the tax wedge is intersecting the demand curve, right? And the point where the tax wedge is intersecting the original supply curve is the price the seller is going to pay, which is P star. So in this case, the seller is still paying the same price, which is P star. The original price was also P star, and the new price for the seller is still P star. Seller is getting the same price, not paying, is getting the same price, but the consumer is now going to pay a price of P star or P plus T. So this actually should be P star plus T. Right? PC we are usually referring to as the consumer price. Okay, so this whole thing is the consumer tax burden. Consumer tax burden we are referring to. Okay, I don't know if you have this expression in your lecture slides, but basically when we say consumer tax burden, we mean how much of the tax the consumer is paying, and producer tax burden is how much of the tax the producer is paying. Okay, so in this case also there is no deadweight loss, but there is going to be some amount of revenue which the government is going to generate. And like, of course, the rest of the things you can calculate as before. You can calculate the producer surplus and the consumer surplus, and you can see the producer surplus is not exactly going to change because, in the diagram. Yeah, I'll do that. Okay. So in this situation, what you see is that the demand curve is a vertical line. So that means what? Where is the demand curve intersecting with the price line? So this is the original price line, right? This is the original price line for the consumer, and this is the new price line. So how will you calculate the consumer surplus? Initially, it would be all of this area, right? Because this whole thing is what? It is infinite, isn't it? If it's if this is bounded only on two sides, or even on just three sides, there's no upper limit because the demand is inelastic. So at any price, the consumer is still buying, right? So in that sense, the consumer is not actually missing out on any sale. And in a way, you can say that the consumer's valuation of that good is, in practical terms, it is infinite, right? So no matter what price the consumer might be paying, they are still getting some positive value out of that sale. So for example, this may be like some life-saving drug like insulin, or I don't know, maybe like if you remember during COVID times, even drugs like methotrexate and things like that, they were kind of in infinite demand, right? Which means that people were buying those drugs at insane prices. So when demand for any good is perfectly inelastic, it means that the people are just not budging. So in consumer surplus terms, it may be a bit difficult to wrap your head around it, but in consumer surplus terms, if you value something infinitely, no matter what you pay for it, you're still happy buying it, right? It's still saving your life. So you still have some valuation of it. And hence, the consumer surplus is going to be infinite. And in this new situation, after the curve has shifted here, let me try another color. So here, now this whole thing is the new consumer surplus, right? So now this niche wala part, this part which is not hashed green, that much part is like in mathematical terms, it looks like it is lost. But in real terms, infinity minus epsilon is still infinity, right? That's what in mathematical terms infinity means, that even if you reduce something from infinity, you still get infinity. So consumer surplus is still infinite, right? In the previous case, the producer surplus was still infinite. But in this case, the producer surplus is not changing. Okay, producer surplus is not infinite because initially before taxes, this was producer surplus. Right? This is the price line, this is the supply curve. And after taxes, this is producer surplus. So tax line and the new supply curve. So you can see these are both are like equivalent triangles. This area is the same. So producer surplus is not changing. Consumer surplus is also not changing because it is infinite before and after taxes. And that is the reason why you don't have deadweight loss. So what I was saying was that, there has to be an intuitive reason for why you don't have deadweight loss. Mathematically, you can say that, okay, after shifting the curve, blah, 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 this is the triangle, blah, blah, blah. But intuitively, that is the reason why, because producer is still, getting, the same kind of surplus, and the consumer is still getting infinite surplus, right? So there is no deadweight loss. There is some revenue generated. So both these examples basically illustrate two things. One is that the person in the trade, like between a consumer and a supplier, the one who has a more inelastic demand or inelastic supply, that person is the one who ends up bearing the tax burden. So in this case, the demand is inelastic and the entire tax burden is falling on the consumer, right? In the previous case, the supply was inelastic and the entire tax burden was falling on the producer. So in both these cases, you can see that the tax imposition in this case is on the seller, but the burden is coming on the consumer. And in the previous case, let me go back to the previous slide. In the previous case, the tax was imposed on the consumer, but the burden was on the producer. Let me annotate this properly again. If this is confusing for you guys. Oops. Let's delete all this. Oh, this I can't delete. Okay, anyway, never mind. So you'll have to just visualize it with this. Now you can see that in this case also, and this red hatching is the the consumer surplus. Consumer surplus is just the same triangle, it is just shifted, and the producer surplus is the same kind of thing. It's infinite because the supply curve is just a vertical line, right? There's one more example I think I wanted to take. Okay, we'll come to that. That is the ad valorem tax. So does that answer your question? Tax revenue and producer surplus are overlapping. 1 minute. In which case are you saying? In the previous one or in this one? In this one. So in this one, let me take another color. Yeah, where is the producer surplus and the tax revenue overlapping? Okay, in this case, this is the original thing and this is the tax revenue. I don't think this is an overestimation. 1 second. Okay, I'll have to think about your question. This is the part tax. I don't want to give you some ad hoc answer. So I will think about this question and I will come back to you. Okay? I don't have a ready answer right now. Somehow I didn't really think about it very deeply. So initially this is the supply curve. Okay, I will think and I will tell you because I know that this is, I mean, it's a good question, but I don't have a ready answer for you right now. I don't think I made any mistake, but I will still just calculate it once again and I'll tell you. Okay, any other question? No? Yes. All right. Okay. So let me go back to our discussion. And okay, this is, I think, the last question. So I don't have a question on the, the one which is the inelastic demand, but there might be some in one of the textbooks which I have given for reference reading. So you can check out these books and you can see if there is any other question. I couldn't, in the time I had, I couldn't find a good one. So in the last question, I want to discuss what I mentioned earlier was the ad valorem tax. Now, this is a question in which you are given the inverse demand curve for a good, and this is P is equal to 100 minus 0.5 Q. And the supply function is given by P is equal to 20 plus zero point 0.3 Q. Okay, and there is an ad valorem tax now. Ad valorem tax is imposed per unit of price. It's not imposed per unit of quantity, but per unit of price. And that is 20% in this case. So now you're asked, after this ad valorem tax, what is the new supply function? So I think I omitted to mention that this tax is imposed on the supplier. Okay, and what is the new supply function? So when you're asking what is the new supply function, what we mean is, how is the supply function going to shift, right? Because when you're imposing the tax on the supplier, it is the supplier curve, supply curve, which actually shifts. So what is the new supply function? And the new equilibrium and consumer price and quantity. So first you can also calculate the original equilibrium price and quantity, and then we will come to the new consumer price quantity equilibrium, because it's good to know how much, we can, how much it is changing. Okay, so I'll give you a few minutes to think this through and to solve it, and then I will solve this. In the meantime, I'll also look up your question. Okay, anyone? Okay, so I think I figured out the answer to your question. So I will come back to this question. Let me just quickly go to your question first. So in both the situations, actually, not just in this one, even in the previous one, the inelastic supply. Let me also erase this actually, clear pen markings. Clear, okay. All right, it's not clearing my pen markings. Nothing can be done. Okay, so in this case, I have, one second. Okay, this is better. Let's go back to the original diagram. So what we were discussing is this thing. Now, in this case, if you see, we are shifting the supply curve to show, the tax burden, right? In this case, because the tax is imposed on the seller, and I want to illustrate that irrespective of the fact that the tax is being imposed on the seller, the burden is actually coming on the consumer. So when we impose this tax wedge, T, which I've marked on the diagram with a bracket, we show that the supply curve shifts to S prime, and the new price from that tax wedge for the consumer is PC, P plus T. So this is the new price for the consumer. But for the price for the producer, PS is still P star, right? So what I don't exactly think it was a mistake, but basically the price for the producer is still P star. So when you're calculating the producer surplus, it is still going to be this triangle. Only difference is that you still have one more part here, which was originally, maybe some part of the original consumer surplus, but now this is becoming tax revenue. But because the consumer's valuation is infinite, this delta change in the consumer surplus is not making any difference in the consumer surplus. So technically, mathematically, you can say that there is a small change in the consumer surplus, which goes into this tax revenue. But in real terms, in the terms of consumer surplus, this change is basically almost zero. And this is becoming the tax revenue. Does that answer your question? Because the price for the producer is not changing. So the producer surplus is still this shaded cyan triangle at the bottom. The new supply curve is just showing the point at which the consumer is going to pay the price. That is what we use the new supply curve for. And similarly, let me also do this thing for the previous question. In this one, so let me delete this. It's become very dirty. Okay, let's shade the same kind of a triangle here also. So this is the original demand curve, which is black line. Supply curve is inelastic. This shaded yellow triangle is the original consumer surplus, right? And we shift the demand curve because the tax is imposed on the buyer. The intersection of the new demand curve with the supply curve gives you the point at which the producer is going to pay the price, right? This point. But price for the consumer is still P star. This is the new price for the producer, right? But because the price for the consumer is not changing in this particular case, this shaded yellow cyan triangle is still the consumer surplus. And this blue, now yellowish triangle is now the new tax revenue. And this is again similar kind of an argument. Initial producer surplus was infinite. You take a small bite out of infinite, it still remains infinite, but this becomes your tax revenue. Okay, similar argument. It's not very complicated, but Yeah, it's a good question. I also had to think about it. Okay, so can I move forward? Come back to the ad valorem tax. All right, so let's go to the ad valorem tax. Okay, let's first go to the question. Yeah, so this is the question. Let me solve this. Sorry. So I hope you can see my screen. Right, so the question is question 8, and this is the inverse demand function, 100 minus 0.5 Q, or we can write QD, and the supply is P is equal to 30 plus 0.3 QS. So I'm just writing QD and QS to denote the demand and supply. T is 20%, and in this case, this is ad valorem. Okay, so let's first solve for the initial equilibrium. It's pretty simple. 100 minus 0.5 Q is equal to 30 plus 0.3 Q. Have I written this correctly? Yeah, sorry, this is 20. Yeah, so this becomes 0.8 Q is equal to 80. Q is 100. Therefore, P is equal to 50. Okay, so initial price and quantity is 50 and 100. Okay, now let's come to what happens with an ad valorem tax. So first, let me solve, the general the general equation for, say, a supply curve. Okay, example. So I'm just solving it for the general case, so you know how to deal with this kind of a question. Supply curve is, say, suppose I'm just writing an algebraic expression. Say P is equal to, what form have we taken? A plus BQ kind of a form, right? Plus BQ. Let's see the question. 1 minute. Yeah, it's A plus BQ kind of form. So I'm just solving it for the A plus BQ case. I'm taking P as the tax, and we will just solve it again by replacing the values of A plus T or whatever. Okay, so now the new price to the consumer is going to be based on the price plus the tax, right? Because the ad valorem tax is being paid by the consumer. Okay, so you have 1 plus T into P, right? Because P, or if you want, I can write it in a simpler way. Let me rewrite this. So the consumer will pay P plus PT because it is based on per unit of price, right? So this is P1 plus T, right? Now, if you want, you can also say that the supplier is receiving P. The supplier is not going to be receiving the same kind of price, right? So we have something like, so you have this equation, P is equal to A plus BQ. Now, P is equal to A plus BQ is what is already given, right? So this is the original P. Now this P, let me write it in another color, 1 minute. This P is price for supplier, and this PC is price for consumer. All right, so now we can just substitute the value of P from the equation which is already given to us from the supply curve. Right, so PC is equal to A plus BQ into 1 plus T, right? Now we can just sort of separate the expressions. You can just simplify this a little bit. A plus BQ into 1 plus AT plus BQT is equal to A into 1 plus T plus BQ into 1 plus T. So what we've done is we have just simplified the expression for the new curve based on just the whatever is given to us, right? So in this case we are given the values of T and P. Sorry, we have to calculate T, we are given A and B we know. So this is like an equivalent expression. So initially we had A plus BQ, now we have A into 1 plus T and B into 1 plus T into Q. So you see, like, basically the coefficients have just changed from A and B to A and 1, A into 1 plus T and B into 1 plus T. So what we can simplify this as is, if in our case, like, the expression originally was our example, we were given P is equal to 20 plus 0.3 Q and T was given as 20% or 0.2. So we can, using this kind of an algebraic equivalence, we can just write the after tax. You get something like PC is equal to A is in this case 20 into 1 plus 0.2 and B is in this case 0.3 into 1 plus 0.2 into Q. Right, this is the new expression. Now you can simplify this and solve it. This becomes 24 and this becomes 1.2 into 3 becomes 36.36. So this is the new shifted supply curve, right? And now you can solve this with the demand equation, which is 100 minus 0.5 Q. You solve these two equations simultaneously, and this becomes 24 plus 0.36 Q is equal to 100 minus 0.5 Q, and this will be 100 minus 24 is 76, and it's equal to 0.86 Q. You can solve this, whatever this comes out to be, unless I've again made some sort of a mistake. Yeah. No, okay, I need a calculator. Can someone calculate and check what this is? So this is 8.37. And similarly, you can solve for P from here. 24 plus this is 2.36. So this is kind of what I get. Let me see if this is the correct answer. So my answer is coming something different. The method is correct. All right. Okay, so again, maybe I have made some kind of a calculation mistake somewhere. We can just recheck that. But is what I did, is that clear to anyone who has any questions? Does this make sense? Any questions about how I got where I got? The answer, I may have made a calculation mistake. I will just check. When I do it too fast, I make mistakes. So we just substituted the value of, okay, so maybe my answer is correct. Maybe what I calculated initially is wrong. I don't know. Because the answer which I have written down in the options is, I think, something different. So yeah, the expression is the same. Maybe I made some initial mistake the last time I solved it. So yeah, so this is basically how we deal with an ad valorem tax. And okay, great, you're getting the same answer. So so then the question, like whatever I've written, the answer is probably wrong. I will modify that. And it's a slightly more complex type of tax. So let me show the diagram. So this is the diagram I created, and these values on the diagram are what I got earlier. So this is just, you can ignore that, it's probably wrong. So but the curve is the same. So you can see that this is the demand curve and this is the supply curve. And when we, if you go back to the expression, I'll just write it here. It's a, so initially we had something like a plus bq is equal to p, and afterwards we had a plus, sorry, not a plus, oops, oh god, why would you do this? Yeah, so a into 1 plus t plus b into 1 plus t q is equal to b p. So this is the new general expression for the curve, and from this you can of course see a into 1 plus t is greater than a, right? So the intercept here is going to increase, and b into 1 plus t is also of course greater than b. And as you can see, because it is an ad valorem tax, it's not just the quantity with which the tax is increasing, the price is also affecting the tax, right? So the curve is sort of deviating. Oops. Yeah, so I don't know why it wants access to camera. So the curve is basically diverging out like that, right? Depending on how steep the, I mean, how great the tax is will decide how steep the curve becomes. So if the tax is very small, that divergence, like here, it may only be something like this. But if it is a lot, it may be something like that, right? So that varies based on how much the tax is. So, this is the problem we face with something like GST, right? So GST is a prime example of a similar kind of a tax where when you buy something, you are not paying in number of units of orders or something like that, right? You're paying based on the price of the good, which is why 18% GST feels like such a big burden, because 18% on the price. So if you're buying the small thing for 50 rupees, even then it's not like it's such a small amount. But if you're buying something like 2,000 rupees, suddenly the tax is a lot, right? It's like 360 rupees just in tax, right? So this kind of keeps increasing, and hence, because of this kind of a tax effect, the change is more significant or is slightly different from the usual tax which we have, like in the per unit tax case, the normal tax which we have. So I think this is all for this week's. I want to go back to the question which I had left in the previous week. I uploaded the correct solution for this question. So if you remember this, there was this question in the previous week, question number 6, in which we were given the supply and demand in logarithmic terms, log QS and log QD, natural logarithm. And it's in terms of P and PT, price of processing tomatoes, and PT is tomato paste or something like that. And you were given the value of PT, which was 102 for the year 2002. And I just simplified this equation for the demand function, this equation. Okay, you plug in the value of PT and you get this demand equation. So before taxes, you solve the equation as we normally do, QS equal to QD. And in this part, in the previous week, I actually made an error. Instead of 0.5 into log 102, I think I had taken something like 0.5 plus log 102. So that's where the huge error was coming from. That's why the answer wasn't making any sense. So I solved it again. This solution is correct, whatever I have uploaded already. So you just plug in the values and you solve for the, the price and the quantity by taking exponents. So you get log P is equal to 4.125. You just simplify the mathematics, you get that. And then you take exponent on both sides. Left hand side you get P, on the right hand side you get e to the power of 4.125, and you get this answer. And quantity you get is this answer, right? So this is the correct answer for that question. And I think there was a second part also for that question, which I had left because this answer was not properly solved. So I wanted to check if anybody attempted that question and if you're getting the correct answer, the second part of it, and well, also the first part of it. So the second part was if there is, I think, a price ceiling or price floor. Let me open it. Okay, let's go to this. Yeah, the government imposes a price support on processing tomatoes at $85 per ton. So price support is minimum price, right? So that's a price floor. You can't reduce prices below $85. This question 6 in the previous week. So the processing firms will now pay $85. And the government will buy as much as the farmers want to sell at that price. So how many tons of tomatoes do the firms buy and how many does the government buy? So I wanted to just discuss this question. So $85 is now the price support, meaning the firms are mandated to buy at that price, right? So there is going to be a difference in demand and supply, right? In this case, suppliers are the farmers, buyers are the firms. So don't get confused about that. Okay, let's just call them buyers and sellers just to avoid confusion. In this case, we know that the equilibrium price is $61.88 and the price support is $85. So obviously at that price, the sellers are willing to sell a whole lot more than whatever quantity we are given. 11.81 is what they were initially selling at, So now at $85, they will sell a whole lot more, which you can solve from this equation, right? This equation. In this equation, if you substitute the value of P to 85, you will get QS. You will have to solve the log part, and you will get the value of QS for 85. But the demand QD at $85 is going to be much lesser, right? Which you will solve from the second equation. Now the second equation, again, for P, you plug in the value 85 and you solve it again like we did and you get the value of QD. So the government purchase, let me write it here itself. Government purchase is equal to QS prime minus QD prime. QS prime and QD prime you get from substituting the value of P in the demand and supply equations, where QS prime and QD prime are obtained by plugging in the value of P prime is equal to $85 into equations 1 and 2. So I had actually explained this in the previous class, but I just wanted to make sure that this is clear. So it's a very small calculation mistake which I made, but because this is logarithm and the mistake was multiplication and addition, the solution kind of went haywire. So this is the correct answer. And I have already updated these new notes on the folder. If you want, you can check it. And I will update it further now with this comment if you guys like. So I think this is like, this completes my stuff for this week. If anybody else wants to ask something, you can go ahead. So I'm once again sharing the folder where I update the slides. You can bookmark it. So NPTEL team should be sending you the link for these things, but I don't know why they've not updated it. So for now, you are going to have to rely on this. Which textbook? So there are several textbooks. Sorry, not this. Yeah. So in the end, I have given a reference reading. So this first one is an online book. It's a free book. The second one is a question bank kind of a book. It's a really good question bank. There is another book, Intermediate Economics by Halvarian, which is the textbook. And this one, Workouts in Intermediate Microeconomics, is more of like questions. And the third one is a basic textbook. It's by Jeffrey Perloff. So these are the three main books I refer to. But there are other books also. If you want, you can refer to them. There is another book by Pindyke and Rubenfield. I will, maybe from time to time, I might refer to that also. You can refer to that if you prefer that book. Mostly, like, there's another book, I think, by Andrew Scotter. That is also a good book, and I have referred to it in the past for some of the chapters. But like, yeah, there are many books you can refer to, whichever book you like at this level, which is at this level, whatever this course is at. And this one is free. Some of them are not free, but if you want, you can find free copies of it somewhere. So I'm also sharing the link for the YouTube playlist where these videos get uploaded, because all these videos are recorded and uploaded. So if you want, you can go back and refer to them. So yeah, anything else? So this reference link is there at the end of all the slides, which I will upload. So you can always refer to it if you're looking for the names of the books. Okay, any other questions? So there are no questions. I think we can end the class. And next class, we'll meet again at the same time. And if there is any question you want me to solve in the class or something like that, you can please go ahead and post it in the discussion forum, and I will take it up in the class. Okay, all right then. All right, thank you everyone for joining. I'll see you next week.